Daphna, for introducing me. My name is Tom, and I'm a software engineer and architect in Wix. In the past 5 years, I've been in the front-end guild. I'm doing many projects and different projects. One of them was Sled, which is the project name, which we will now talk about. I'm super excited, and I hope you guys are excited too. I obviously can't hear or see you, so I'll just try to move along. And besides what Daphna says, if you guys have any question or anything you want to ask, feel free to ask in the chat. And in between the slides, I will stop and see that everyone understood, and we can answer questions in between as well. So welcome again. In this meetup, we're gonna walk through the basic concepts of building your own cloud-based end-to-end testing platform. It sounds very fancy and very big, but as time will go by and we'll go through the slides, you will see that even though it sounds very, very big, it's not. It's a very cool concept and very easy to reproduce. As a matter of fact, it's not going to be a meetup where we're just going to talk and I'm going to tell you how we did this and how we did that, but we're actually going to walk through a project, a very simple project, which I will publish its URL at the end of the slides, and you can all pretty much set up it on your own and have fun and play with it. And it will actually, and we'll talk about it later, it will actually pretty much scale to a lot of tests. We will look into the numbers later. But again, I'm super excited. I hope you guys as well. And let's start. So how to run 1,000 end-to-end tests in 5 minutes with Sled. So this lecture or this meetup will be consisted of 4 parts. First of all, we're going to talk about the end-to-end problem and how we approached it in Wix. And part of the way we approach it, we thought of this solution, which we call Sled. We're going to present it. Then in the most interesting part, in my opinion, we're actually going to look into the project that I made. And we're going to talk about it, how you can build your own Sled. And at the end, I also want to talk, you will see a very simplified version of Sled, but it's the core of this platform. But in the end, I would like to talk about how we supercharge it and how we make it scale in the numbers that we're currently using scale today at Wix. So the end-to-end problem, I'm going to talk, and I assume you guys and girls are coming from different backgrounds. Some of you are DevOps, some of you I saw are mobile engineers, some of you are front-end, like myself, some of you could be back-end or system or whatever. I will try to keep things as simplified as possible so you can all pretty much understand, but I do have to apologize that when we're going to talk about code and about technologies, it's going to be in the front-end environment, meaning that we're going to talk about Node.js runtime and tools and stuff that we use mainly on front-end projects. But again, Node is very simple and everyone can start using it immediately. And if not, you can ask for a friend to help you with it. But again, I'll try to keep things as simplified as possible. So talking about the end-to-end, when we approached this problem, I think 2 years ago at Wix, we actually went through different teams and projects and talked to the people there. And we tried to understand why are they not writing enough end-to-end tests. Obviously, and I assume it's the same for other companies as well in the industry, obviously writing end-to-end is a very valuable thing. You get a very, very good feedback on your code changes and you test your entire system. Here in Wix, our system, as you probably heard in other Meetup or somewhere else, Wix has a lot of services. We use different architectures, different tools, and every time, actually I think the average is every 4 or 5 minutes, there's a production change in Wix's ecosystem or environment. So end-to-end is critical for us, and I assume it's critical for most companies. One important note to say is when I'm talking about end-to-end, because I'm a front-end engineer, I'm talking about browser testing, as opposed to maybe in other fields in the industry when they talk about end-to-end, they're talking about other stuff. Here we're going to talk about browser testing end-to-end. So again, when we tackle this problem and we went around and talked to people in Wix, pretty much you can sum it to a very simple sentence that every developer said that the end-to-end test is needed, but they are slow and they are flaky. And when you hear this word slow and flaky, it's pretty much clear what we're talking about and what it means. But we started to think about how we can solve it. And we understand that end-to-end tests are slow because obviously you're using the browser, and the browser was meant for humans and not for automation. And obviously things can go wrong, especially with sending events in the browser and all this complexity. So we understood that there are some inherited problems that cause end-to-end tests to be flaky and obviously slow. Browser is a very, let's call it a heavy piece of software that if you're automating it and using it heavily. But on the other hand, we didn't want to tackle this directly. We tried to think of another way how to understand the problem. So what we did is that we looked at the process that our engineers are going through. And this is obviously, obviously the process is embedded in CI. So let's try to think of the average developer. He or she, they write the code on their local machine, they make their changes, and they do the local build to make sure that everything passes and everything is compiled and transpiled and whatnot. And once they have their code under test ready or bundled, or whatever you want to call it, they will usually do the local end-to-end test. They will test whatever they want on their local machine. Then if everything passed and they didn't find any bug or anything, they will push it to CI. This part, we call it the CI unknowns. It's something that I assume that a lot of companies are facing, is that CI is very, very complex, and it's a very, very big system that has a lot of dependencies. So once in a while, and sometimes it's even once a day, you get some unknowns that you're blocked or you're waiting for a dependency of your project to finish their build, and sometimes there are problems. So it's a huge step, and sometimes it will take you, I don't know, if it could be 30 minutes till your CI build will start, sometimes even more. And then at the end, if everything passes, you will obviously run the same end-to-end that you ran on your machine. You'll run it on CI, and the developer will get its feedback that everything passed the test that he made. Now, obviously, I'm not talking about a single test. As the projects are more and more complex, you have a huge suite of tests. Could be dozens, could be hundreds, and in Wix's case, sometimes it's even thousands for a project. So going back to the original problem, we try to think how we can make, or what will be the ideal solution, how we can minimize this entire huge process. I hope you can see my cursor, or what I'm marking at the moment. And we tried to come up with the ideal and theoretical solution for how we make this thing as quick as possible. And we came up with, obviously, again, it's a theoretical solution where every time you make your code changes, you make your local build, you build it, it passes, and then you immediately run end-to-end and you get the feedback. So pretty much passing or walking around all this long and very complicated and mostly slow CI builds. And this was the ideal solution. And we tried to think, if this is the ideal solution, what would we need in order to accomplish it? Again, as a concept, as a general guideline. And we came up with two important guidelines. The first one is that if we want to have this simple and quick cycle, we would like to have ultra-fast feedback, meaning that from the second that your code changes to the second you get the feedback, it has to be really, really quick. Now, obviously, where the alternative is sometimes it could be 15 minutes at best, sometimes it could be half a day. So ultra-fast in this, under these circumstances, sometimes could be even half an hour. But again, we just work with our gut feelings, and we think that ultra-fast feedback should be something in a matter of a few minutes. But again, it was just the theory part. Now, the second part was we came up, or we understood that because we want to skip basically the CI, again, in an ideal world, we would like to skip CI, then the end-to-end has to be run on a dedicated and a single and dedicated runtime. When I say runtime, and I hope most of you understand me, but I'll try to be clear. When I say runtime, I'm talking about like the machine or the environment that the actual physical browser would be executed on. Because we're talking about end-to-end problems and end-to-end tests, we obviously need a browser, a real browser to be executed on, meaning either a real machine, which is obviously not relevant at this time in the 21st century, but should be some kind of virtual machine or whatever machine we have access to. And you can pretty much understand that when we're talking about a single and dedicated runtime, we're talking either about stuff like Docker, which can replicate the same environment in your machine, or something that has to be remote. And there's a little hint here with the cloud, is that we went for, or our hunch was that we need something remote. So again, we're just in the initial outline. We try to came up with the ideal solution, and now when we have this ideal solution, we try to came up with the outline. And now where things will actually be much more specific, we'll try to drill down. So again, in the last slide, we talk about the ideal solution of doing end-to-end. And now we're going to talk about the outline of a more specific way of reaching it, because again, we have something that is very ideal and very nice to talk about in theory, but we need to implement it somehow. So I'm saving you a lot of time by going to, we did a lot of POCs and we played around with several solutions. The irony is that the POC was done a few months before we ran into this problem and we started to think of it. POC in weeks, and we took it and we looked into it a little bit, and we basically realized that this solution is good enough for us. And the solution, I can sum it up in a single sentence, which is parallel execution of an infinite number of tests, right? The N stands for like an unknown or infinite, as far as I care, number of test files on a remote runtime. So this is the outline for the entire solution. Now, before like diving into the actual solution, I want you to understand why this simple outline sentence or concept was very radical for us. Once we established this principle, which we started and we looked around at the POC and we obviously play with it a little bit, we realized two important things. The first thing is that tests are more stable. I don't have a number because it's very hard to sum it to a specific number or rate or percentage, but tests are more stable when you have a dedicated and optimized and proven. There should be a big emphasis on the proven part for headless browser. I want to rephrase it or try to better explain it. Usually when you run, or at least it was for weeks, I assume it's for other companies as well, usually end-to-end tests either run on a third-party solution, depends on the type of test, or so you have a dedicated runtime, but it's being managed and maintained by someone else, or you just take a CI machine and you tweak it around if needed. You install a thing or two, you install a executable of a browser executable, a headless browser executable, and you pretty much use it. And that's okay, but we realize that if you will use a remote runtime, and I will talk in a second about which runtime is that, but if you will use the one that is really proven in the industry to be useful and dedicated and optimized for this browser, you automatically gain stability. If you recall, the two major issues or the complaints were that tests are slow and unstable or flaky. So this is the flaky part. We understood that we will mitigate dramatically or at least significantly the instability or instability issues only or just by using a dedicated runtime. So that's the first part. And the second part, it's the parallel execution, which I assume you guys understand what it means. But just to be clear, usually when you run a test suite, doesn't matter if it's end-to-end or unit test or whatever, usually it's being executed. Let's say it could be, let's say you have 100 test files. Usually you will run only some of them in parallel, like in a testing framework we use in JavaScript or in Node, called Jest. So it will do some sort of parallel execution, but it will be on the same machine. So, but again, if you have 100 tests, usually it will do parallel execution based on the number of CPU or cores you have on the machine. But when I'm talking about parallel, I'm talking about pure parallel, meaning that you will, if you have 100 test file, you will have 100 executions pretty much at the same time, give or take network latency and stuff like that. And what we realize, and this is a critical and important thing to understand, is that parallel execution will actually lead to zero time cost for retrying failed tests, which will actually, and I'm sorry if it will sound brutal or very, very naive, but it will actually statistically reduce the instability, or actually not even reduce, it will actually let you overcome instability in a statistic matter. Meaning, I'll try to better explain it because it's a critical, it's a very, very critical thing to understand. We can't, as I said at the beginning, we can't solve the inherent problems of browser test being flaky. It's related to a lot of complex concepts and obstacles you have in a browser. As I said, it wasn't meant for automation. When you work or when you automate browser and you're using stuff like Selenium or Puppeteer, which are the browser driver libraries, you actually talk with a specific protocol of this browser, and this protocol wasn't meant for automating actions. It was meant to do other stuffs as well. So here and there you get stuff like missing input characters, or just a browser that doesn't come up. And again, we can like open the source code for Chromium and try to fix all the stability problems or wait for someone else to do. But I think it's much less practical. What you really can do, and again, it sounds very, very simple or very brutal, but in fact, it's extremely expensive because you execute all the tests, and it's what I call sort of pure parallel execution, because you execute them all at the same time. Retrying a failed test, or actually invoking it twice at the same time, will actually mean zero time cost, as opposed to sequential execution, which most of the times this is how end-to-end tests are executed. So because you can do that, you can actually look at the same results for the same test if you execute the same test 3 times. And you can say that if it failed, I don't know, 1 out of 3 or 2 out of 3, you're okay with it. You can obviously enrich it with a much more complex logic, try to understand maybe, or implement a heuristic that tries to understand why it failed. And maybe for some failures, you won't be so graceful, but for some you will. But one way or another, and again, it's proven, it's not something that we do in like a minor project. Sled, I will talk about it later, is deployed entirely in weeks. As far as I know, I didn't check it for the past year, but obviously all big projects in weeks are using it. Maybe there's like a few POCs that doesn't, but that's the official testing framework for us, and it works. It's effective. Statistically handling instability just works. If you have any questions, I think because it's a very important part but tricky to understand, feel free to ask now in the chat or in the Q&A. Oh, we have a question. Yes. So how do you avoid false negatives? How do you ensure that you do not miss a rare bug? So as I said, statistically, you could face or you could miss a rare bug, but again, you just said it yourself. If it's rare, then it's rare. It will happen once in a while. The question is, again, it's something that you have to do. It's different in between projects and in between needs. But there is this chance, obviously, that statistically you will ignore this very, very rare bug. But again, it's a matter of scale. If you will run just enough, and by the way, you can always monitor it. So you can identify, eventually you can identify these rare bugs. So it's something you can always do. A proven runtime, meaning a runtime, here's a spoiler. It's AWS Lambda. We're going to see it in 2 minutes. But proven meaning that it has been used in the industry and in several projects outside of Wix that we've seen and we've read and we've experienced. It was used in production to run headless browser. So as far as I'm concerned, this is proven. Okay. And now I'll move on to introducing sled. So just going back again, this was the outline, this was the concept, this is where we wanted, and we understood what is the ideal design or very, very initial architecture. And now let's move on to understand what sled really is. So let's like talking before all the fancy charts and everything. So sled, the tagline is sled is a cloud-based end-to-end testing framework. And now we're going to talk about the technology. So we're using 4 fundamentals, technology or tools or whatever you want to call them. First of all, Jest. Jest, it's our core testing framework. Some of you, Jest is open source, developed by Facebook. Very, very useful, very, very fast, even for local executions. They use the limited by the cores parallelism I talked about, meaning it will calculate the number of your cores on your machine, and it will run that number of tests in parallel. Obviously, it's not good enough for the parallel that we want to reach, but still, it's a great framework for testing. We use it heavily in Wix, so we took it. There's also, and you will see in the project, they also have a great API for extending it and overriding some capabilities, which was very, very useful in our POC. So we went on with it. So that's for Jest, a very, very trivial decision. By the way, sled is, I didn't say it, and it's a fancy word that we always love to use it in software. Sled is opinionated. We support a single instance of every type of technology that we will just talk about. But still, sled is, you can obviously change it and replace sled with, I don't know, Karma or whatever. I'm not sure what the kids are using today, but we're using Jest. But you can obviously use another testing framework. Chromium, this is our test browser. Now, this is usually, in this part, there's a lot of questions about cross-browser testing. So I will answer this question, this very common question now. Here at Wix, because of the issues that we're facing, and because of the complexity of our system, we put the cross-browser testing is not our #1 priority. It's being done by other teams in other means. We have a QA guild, we have automation guild. They also handle this problem. But as front-end or back-end doesn't really matter, as developers, what we need is a tool that we control. And the cross-browser testing is in let's say, a lower priority for us. The complex and very, very critical problems, the critical path of our applications are obviously either on the back end or on the front end. But the cross-browser or the different rendering engines of the browser is usually not our top concern for this type of problems. So yeah, we're using, in this part, we're very, very opinionated. We're using Chromium. By the way, as I said, proven runtime, I was talking about the remote runtime, but I think Chromium as a headless browser is actually, as far as I'm concerned, part of this proven runtime part. Also, an important note is that when I say Chromium, I'm just aligning myself with, just to be honest and clear that we're using the actual Chromium, but for those of you who doesn't know, Chrome and Chromium is pretty much the same thing. Chrome is like a layer that lives on top of Chromium and related to user experience and some stuff that Google are doing. I'm not exactly familiar with all its features, but in its rendering engine part, in its JavaScript engine part, it's the same browser as Chrome. And as far as I recall, it's being slowly adopted by other browsers as well. I think the new Edge or whatever its name is, I totally forgot. And also, okay, this is what Puppeteer, but there's also support in Firefox, which leads me to the next point of Puppeteer being our browser driver library. Puppeteer is, in theory, it should have been agnostic. Yeah, the new Edge. Okay, so someone says that the new Edge is Edge. Yeah, I totally forgot. I thought there's a new name because they love changing their names, but yes, so Edge. Sorry, back to Puppeteer. So Puppeteer is our browser driver library. Again, as far as I'm concerned, part of the proven runtime ideology. Puppeteer is a great alternative for those of you who ever used Selenium. It's, in my opinion, a much better alternative to Chromium. Much better alternative to Selenium. It's being maintained by Google. It's a great piece of code. I personally pushed a few commits there. It's very, very easy to walk around to understand how Puppeteer works. It also has, and this is like low-level stuff, but it also has a great advantage that Puppeteer works on top of another open source protocol, or a protocol that is being used in Chrome, called the Chrome Debugging Protocol. You can read about it. And sometimes, and we use it heavily, sometimes you can like eject yourself out of Puppeteer and use the low level or the underlying protocol underneath it, so you can achieve or support a much more complex scenarios that sometimes Puppeteer API is just simply not supporting. So that's a great advantage for Puppeteer. And again, it's an open source project, very common and very battle tested. And the fourth thing, and I'm not sure how many DevOps people are around, but this usually leads to a lot of discussions and rumble and noise in the crowd. But because I can't hear or see you, so I assume that some of you right now are not very happy. But all I can say to you is that when we thought about which type of cloud technology to use, we actually heavily tried two. One is the Google Cloud. The other one is AWS Lambda. And we also have an article, I can maybe share it later. We did some benchmarks, I think like a year and a half ago, on which cloud runtime to use. And eventually, and again, my apologies for all you Google people or people that really likes other cloud infrastructure, but AWS Lambda took them all in terms of performance, ease of use, and some other functionality that we needed, and I'm not gonna go into it. So this is pretty much, we're gonna see the architecture in a second, but this is pretty much the core fundamental or the core technologies that we use when we wrote sled. There isn't really much more than that in terms of libraries, only for very specific use cases. This is the core, and we've been using it for the past, I don't know, 2 years, 1.5 years. It worked great. And for questions about technology, if you guys are okay with it, and I assume you do because I can't hear you, we're going to talk about technologies in the end if you have any questions about it. I know it's usually a topic that brings a lot out of people and people have a lot of opinions, but I'd like to move on to the architecture part. So now we've reached the fancy part of sketches and this lovely chart, which I personally drew. If you were here, you should have clapped me because yeah, I did it. I did it on my own, so I'm very proud of myself. So let's try to understand how sled works, how the architecture works, now that we understand what are guidelines and what we want to achieve and what are our core technologies. Let's see how it works on a whiteboard. So the first step, and here I encourage you to ask questions because this is probably the most important part for you guys before we move on to actually seeing code. So we're going to do it in 4 simple steps. The first steps is our entry point or our starting point. And this is an important thing to understand. It's either it's a local developer that sits at home or in the office, currently at home, and working and trying to get a quick feedback and to end-to-end test his code changes, or whether it's CI, as far as I'm concerned, it's the same thing. Okay, it's a very critical thing to understand. Because we wanted to break the chain of being dependent on CI, we actually had to develop a solution that will apply both to CI and local dev in the same manner exactly. So we start with the local dev or CI. Let's say that we have this test and we made some code changes and now we want to test it. So the first thing we do is that we actually initiate or we run the test that we just wrote. We run it as if it was a normal Jest, a normal test on our machine. We use Jest, the vanilla Jest, nothing changes at this point, and you just run your Jest test. But now things are becoming more interesting, and it will be much more clear when we'll see the code. But instead of just running the simple Jest on our machine, what we do is that we override Jest or extending its API, and instead of letting Jest do its magic and run the same test locally and set up the browser and whatnot, what we do is that we invoke Lambda Executions. And this part I want to better explain. Lambda, for those of you who are not fully aware of it, Lambda is a service by AWS, by their cloud. It's pretty much similar to functions in Google, and it's in its essence, it's just a function. It supports, by the way, multiple runtimes. It could be in Python and Node and some other stuff, and very, very useful. It's a very, very developed and very, very successful product. And I'm not trying to do PR to Amazon. I'm just sharing our experience with it. And what we do is that we just invoke it. And by invoking, in its essence, you're using AWS SDK, but in its essence, invoking is just sending a simple HTTP request to the Lambda, invoking it, assuming you have the right local credentials. So Amazon will authenticate you as, or authorize you as a user that can do it. And you will pretty much just invoke a function, but instead of doing it locally, you will do it remotely. And you will do it one for every test file. So if you have 100 test files, you will, by extending Jest API, we will invoke it pretty much at the same time. Like it will be sequential, but just the invocation, and invocation is very, very quick. So you're going to invoke, and you're pretty much going to set up or spin up 100 different functions on the AWS cloud, or 100 Lambdas pretty much at the same time. And another thing that we will later look at the code is that we will bring with us, or let's be more technological, we will upload, or we will pass in the invocation parameter all the data we need in order to run this test. So you can obviously guess that we're talking about the actual test content, like the actual file content, because we execute only a single file, and some sort of configuration, which is not that relevant at the moment. But this is pretty much an invocation. Again, what you need to understand is it's nothing but sending a simple HTTP request. So that's the first part. Once we did that, we actually accessed the AWS cloud, and we're running the same Lambda 100 times, because we have 100 test files at the same time. And as you recall, when we talked about all the technologies and tools we're using, every Lambda is pre-configured with Jest, which is obviously, and now this is a tricky part, but you have to understand that there are now 2 instances of Jest running. The first Jest is running on your local machine, or CI, whatever, and thinking it's running the actual test, but because we extended it or overriding some behaviors, instead of really running the test, we just pass all the data to the Lambda, and in the Lambda, the real Jest, or the remote Jest, actually kicks in and start executing the code. I can see another question, which is great. I will answer in a second, but please, because I'm not that familiar with the Zoom, or not very successful with it, please write in the chat so I can see it. Sorry. Again, we open, or we invoke or spin up 100 different Lambdas at the same time. Each one is pre-configured with Jest, with Chromium, or headless Chromium, meaning the actual binary, the same binary you have, the same binary file that you have on your machine. We pre-configure it, or we pre-install it on the Lambda. In the example project, I will explain how. And the last thing that we have there installed is the Puppeteer, the driver library that knows how to interact with Chromium. Now, if you think about it for a second, and I know it sounds a bit weird, or for some of you, it won't make any sense, but what you need to understand is that in how Lambda runtime works, it's a Node.js runtime, it's pretty much the same, although the operating system, the underlying operating system is a bit different. It's pretty much like running the same thing in your local machine, only you do it 100 times on different Lambdas. So you invoke the test, that's number one. The Lambda spins up, just spins up. You launch, and this is the internals here, you launch the browser and you just run with just a single test files. And what happened there, and this is a very easy step to understand, is that you just, once you executed the test, it takes it, I don't know, it can take the test a few seconds, it could take the test 10 seconds or even 5 minutes, doesn't really matter. Eventually you get a result. And that result is just passed back to your local machine. Now, it's important to say, because it's pretty much the same Jest instance, no, not instance, the same Jest version, then, and this is a tricky part to understand, but I'll try to be as clear as I can. Once this execution is over, the result, the payload, is actually a JSON describing the test result. And instead of being processed here, it's being thrown or returned back by invoking this Lambda back to here. It's actually this part, right? You open a connection, you send an HTTP request, you wait for it, and you get a response back. And that response contains a very, very plain, simple JSON. Everyone can read it. This JSON is in the format that Jest can read, and the local Jest, which is the Jest that we ran here, just processes this JSON and shows the results as if the test ran in the same machine. So we we work around Jest, or we fool Jest to think that the test was executed here, but in fact we just executed on the Lambda remotely. We did 100 times, and we just sending the results back. So this is step number 3, and number 4 is pretty much the same thing. The local Jest will print the results. So this is the top level architecture. Again, we're doing it step by step. It will be much more clear in the next step. I actually will look into the code, but still now for the questions part, I want you, if you have any questions, I will try to refer them now, just to make sure that everyone understood this architecture before we dive into the code or see the actual code. Okay, so could you show how a report example looks like? Yeah, we will see it later. Would like to see how developer gets notified when lots of tests done. Yeah, okay, so we will see it in the live demo, which I'm taking the risk to show you and perform a live demo. What about cost? I was waiting for these questions. Was money a consideration? Yeah, so let's talk about the cost when we will see the actual scale that we do it in weeks. I think you will understand why it's not really a consideration. But ask this question again. It's not that relevant to the architecture, but it's a very important question for those of you who would like to implement it in their own company. Another question, how large is the file uploaded to Lambda with the Chromium binary? That's an awesome question. I will refer it now, although it's a very, very technical part, but it's actually a very interesting part. So again, how large? So the Chromium binary, I'm not sure if the person that asked it already ran into Lambda issues, but there's a certain issue with it. Lambda limiting, sorry, the size of, remember that we pre-installed this Jest and Chromium and Puppeteer stuff beforehand on the Lambda. We obviously don't install it whenever we invoke it. So Lambda sort of has their limitation. To be honest, the last time I actually left this project, and I'm doing other stuff now in weeks because it was a while ago, but still, as far as I recall, the limit was 250 megabytes for like the pre-installed part of all the libraries you need. And the person that asked these questions rightfully asked it because the Chromium is a very, very significant part of it. I think on macOS, Chromium is a binary, so obviously you can't really compress it, or you can, I'll talk about it in a second, but you can't really compress it, and Chromium alone is like 100 megabyte. So easily, maybe in this very simplified version of sled, the package size is not an issue, but in reality, you have other stuff like internal stuff and packages that you would like to pre-install. So the 100 megabyte is an issue. And we are using, or in order to solve it, we're using a great open source project, very, very critical, by the way, for us. It's called Chrome AWS Lambda. I didn't mention it, it was a mistake, but Chrome AWS Lambda, it's open source on GitHub, you can see it. This open source project actually solved the Chromium or bundle size, or not bundle size, the Chromium size, disk size problem by actually compressing it using the Botley algorithm developed by Google, I think. And it knows how to more efficiently Botley compress binaries and other stuff. We're also using it in our CDNs, in certain CDNs. It shows a much better compression ratio. So this package uses this Botley mechanism algorithm, to actually compress Chromium to be much smaller than it is. I think it's being compressed to like 20 or 30 megabytes. And in that way, we can easily handle it and upload it to the Lambda preloading configuration. And again, just to be clear, you will see it in the code. This entire package, which is being installed and beforehand, is being done way before the invocation happens. So in the invocation, you already have this Lambda with all its installation ready. How do you manage, and this is the last questions, and the last question, how do you manage test, dataset, and mocks? I'm not sure what a dataset means in this context, but I assume when you're asking about mocks, you're talking about like the environment. So and like our environment, our production environment. And if that's the question, then we're gonna answer it in the next slide. And one last question, sorry, I can't help it. How do you send your artifacts from local machines to Lambda? Great question, I'm gonna talk about it a bit later. Awesome. So this is the architecture. And one thing to talk about, or one last thing to talk about before we deep dive into the code is actually something that no one asked so far, or maybe try to ask it, is how we test our code changes. If you recall, going back to this example, I told you that we do run this test and we somehow pass it or upload it. It doesn't really matter at the moment how we upload it to each Lambda, but we also need to test the actual code under change because we just made changes. So in trying to describe it in highlights, there's two types of code for us. There's the front-end code, which is usually scripts and assets, different assets like CSS and stuff like that. What we do with that is that, as you recall, we're doing a local build before we run our test, like we obviously should. And when we do this local build, we take all these artifacts, which is the bundles and JavaScript and stuff we have, and we just compress it in a very, very simple fashion, nothing fancy, and we upload it with the same execution. If you want to be more specific, so what we do is that we're leveraging S3, which is, as most of you probably know, this is like the Amazon, the AWS solution for storage, static storage. So we just upload it from our machines in CI because we're living in the same environment as AWS, like the same data centers and stuff, and we're in the same region. Then it takes nothing. It takes like a matter of between a few dozen milliseconds to a few hundred, no more than that, to upload our entire bundle. And it's great for front-end code because once we upload to S3, when the execution starts, in the execution argument, we just pass in like an ID, and we download it immediately from S3. If you think about it, you have Lambda and S3 on the same data center in AWS Cloud, so downloading is nothing. It's not something you even need to measure. And we just we use it locally. We inject it through Puppeteer. It's a very low-level concept, but there's a concept called network interceptor. Network interceptor, pretty much in the Basel library, allows you to identify certain network requests, and instead of passing them on, you just return a different result or a different. If it's a script, you obviously return a different script. This is how we face front-end code. By the way, this concept can be easily replicated and used by all other projects. It's very, very generic, nothing special here. For every time you have your code under test is a front-end code, it's consumed by the browser, you can pretty much do it. What you can't do, and this varies between different companies, is handle the backend code. Now, backend code could be either the actual server code, or we have a lot of what we call front-end servers, which are in charge of rendering specific mission-critical applications. So in that case, we have like predefined setup in our CI, because we're very like continuous delivery oriented, is that where before the test starts, usually it happens on CI, but you can do it locally sometimes as well. You pre-deploy whatever you want. Let's say you have like a different or like an RC version of your code, and you deploy it, and you get like a hash or some kind of identifier, and we pass it when we invoke the Lambda as part of the test configuration, and we just wiring, either it's a query palm in the URL, or we're just wiring the setup to be routed to a different server. That's pretty much how we do in a very high-level manner. This is how we do backend code testing. But obviously, it varies and differs between the different teams and companies in other companies and in other teams outside of Wix. So it's up for you to decide and to understand how. So that's an important question and an important issue to talk about. And now we're gonna dive into the code. Let's see if there's any other question that I need to talk about now. Yeah, no. So I think we pretty much answered the questions. And let's see. You should now see my Visual Studio. Daphne just confirmed that everyone can see it, so I can move on.
Yes, that's great.
Excellent. So this project that I will now show is, sorry, going back to the presentation, I forgot. Before we dive into the project, I just want you guys to see. This is, remember this beautiful sketch I made? So this is the entire platform core. And although we use sled, or we enhance sled in the past year and a half, we made some dramatic changes in its core. It's pretty much what we're going to see now. And the most important thing for you to understand, it's probably the last thing, or the most important thing I want you to remember, is that at the end of the slides, I will publish the URL and I will tell you where you can find. You can take this entire project. The only thing that I couldn't supply to you is obviously authenticated with the AWS SDK. You have to somehow authenticate with AWS. So you have to open an account. You have to obviously open a Lambda function, create a Lambda function. And I pretty much packed it and simplified the entire platform to this very simple project. It consists of two parts. Now that you understand the architecture, I can better explain it. The first part is what we call the local part, meaning it's pretty much the test, which is not really part of the platform. It's what the platform is executing. So this is an example for a test. But the only thing that is really needed is the Jest Lambda runner, which is how we extend Jest. And I'm sorry that now we're being very specific, but again, what I'm doing here can be achieved in other frameworks as well, testing frameworks, I mean. But as I said, Jest has this notion of extending it. And what we have here is just, it's actually one file. This is just the index file. There's one file that overrides the default, just call it the test runner. It overrides the default test runner behavior, and instead of running it, just invoking the Lambda. So just this part, basically, it's just this module that you need in order to achieve or to implement the platform core on the local side, on the project side. Right? You have to assume that this entire project actually has a code under tests and stuff like this. We will only focus on the test part. And the second part, the remote part, I put it in the project for convenience, but obviously you don't need it locally. You will need to, there's two parts. There's the layer, which is how the concept of AWS for pre-deploying all your dependencies. I made a script for you based on that Chrome AWS project that you can use in order to bundle and package and create one zip file that all you have to do is upload it as a layer to your function. And this is the function code which we'll review, but it's pretty much only 3 files. You will see how short and how clean they are. And this is all you need in order to implement this platform, the platform core. It should take you, in my opinion, I don't know, maybe if you will you will walk around, you will try to realize how to authenticate with maybe open a Lambda, but it shouldn't take you more than an hour to get things up and running. And as I told you, in terms of scale, like infra scale, it will scale. It doesn't matter if you have 4 tests here or 100 tests here. It will, because the heavy lifting part is done on the AWS side, and AWS is a great infrastructure, then this entire project will scale, and you can start using it maybe in a simple project or a POC project in your own team or company. And soon you can look into the concept, see what the problems that you want to solve, and you can easily extend it to be reusable in other parts of your company or team, if you like. So this is the highlight of what we're gonna walk through. Any question before we dive into the code? Yeah, so there's question one, backend for all parallel tests. And no, so every Lambda is, you have to consider that every Lambda is a backend. Have you played with Playwright instead of Puppeteer? No, and to be honest, I'm not even sure what Playwright is. So yeah. Again, you can, Daphne, they can see my VS Code?
Yes, yes.
Great, so let's go. This is the project. You can clone it afterwards. I will publish the URL. It consists from the stuff that I talked about. I will check out to step number 1, so it will be much more easy to understand. And in this step, what we have is we have the, again, we have the package JSON is the entry point for the entire project. It's where we define what our dependencies are and what our commands are. The only thing you need to understand here, even if you don't understand or you never played with Node or any JavaScript project, what you need to understand is that we have these 2 dependencies, initial dependencies. Create Jest runner is just a wrapper, a nice wrapper to use that saves a lot of boilerplate in order to override or extend Jest to have our own custom test runner. And Jest is, well, just a framework itself, nothing special here. One configuration that we have is that we tell Jest, the local framework, that instead of using the default runner, it should use our own runner. And this is our entry point. So we go to the runner, and just to be clear, our test is very, very simple one. It has nothing to do with browser at the moment, because it's not that we haven't reached this step. It's just a simple, very, very simple test. Sorry, yeah, that you can see here. And going back to the configuration, then we start with the test runner. For step 1, we're not going to talk about how we invoke Lambda. The only thing I want you to understand is that this is how a test runner in Jest looks like. It gets as an argument the test path, which is just the file path of the test that is currently running. Another thing you need to understand is that the test runner, which is actually just an async function, will be run 1 per test file. So if you have 3 test files, this function will be invoked 3 times, which made things much more easy for us because it's in the same design or architecture as the Lambda that will evoke, meaning that we have 1 test runner per Lambda. So we get the test path. And in this case, I just want you to understand how a test runner works. The only thing that we will do is that we will randomly decide if this test passes or fails. Nothing more than that. But what you need to understand is that instead of running this test, Jest will just run our test runner, and it will randomly fail or pass this test. No need to, I will save time with demoing this, but you just need to understand that it will work, and it will work great. And this is for step 1. So just overriding or extending the test runner. For step 2, and again, we don't have to go line by line because it's not that important. You can have a look on it later. So for step number 2, instead of randomly deciding if a test fails or pass, what we do is that we will invoke the Lambda. This is just the usage of the SDK. This is the function name. 2 arguments, and this is an important part, 2 arguments that we will need. First one is the test file name. I just took the last part. It doesn't really matter. You can take the entire path. It's just for identifying the actual file. But as I said, every Lambda is executing a single file, so you don't really need to look in the entire file system. So this is the first argument, and the second argument. And I went for a very, very naive approach. I just read the file content as string, and I pass it on, and that's it. Someone asked, and I answered that in real sled, what we do is that we, instead of just passing the content, we upload the entire test suite and bundles and whatever we need to S3. But for our demo, I think it's good enough. And this is the results part. It's very technical. So once you invoke the Lambda, you will get the result, the payload. you will parse it, and you will extract the test result for that specific test file. And from that on, and you will see it in the live demo, will just parse the result and show you the test as if it ran locally. So that's for the Jest Lambda runner part. And the second part for this step is actually the Lambda itself, or just the skeleton of it. So this is an important part. This is how a Lambda looks like. Okay, it's just export a property called the handler. It gets an event. An event is just the arguments that you pass on when you invoke a Lambda. And in our initial Lambda in step 2, which is not like production ready yet, we're just doing two things. The first thing is that we take the argument, the Lambda invocation argument, which is, you can see here, the test file name and the content, and we set up a local project, meaning that we write directly into the Lambda file system. I'll show you it in a second. And we're just preparing Jest to run locally. Because how Jest works, Jest is eventually when you run Jest, it will look on your local file system. So we just use the temp path in Lambda. You have access to it, and you can just write. We're just generating like a unique number. We're creating the dir, meaning the directory where the test lies, so it's unique. And the only thing we do is that we write the test file itself. So this file will just be written locally in the temp directory with a specific ID. And the next thing we do is it's a Jest detail. We're just creating an empty configuration file for Jest to run. So that's the local, like the Lambda local file system setup. And once we have that, we just run Jest in a very, very simple and straightforward manner with two simple arguments. We tell them that the JSON, like the output should be in JSON instead of writing to the standard output. Verbose is just to clean up some logs. And then we tell him that your root project is here, where we just set up the test file. See if we have any question for a second. So yeah, no question. We can move on to step number 3. I hope you guys understood it. We have the Lambda and we have the Jest runner that now, again, knows how to invoke the Lambda that we will set up beforehand. Now the third thing to do, which is step 3, is actually here nothing has changed. Step number 3 is the layer. Now, as I told you, the layer is a very simple concept in AWS. It allows you to pre-install and have all the dependencies you need in like a very, very convenient way where you can basically separate between the function code, which is like the runtime code that is being executed on the actual Lambda, and the dependencies part. So it's like a separation of concern. You don't need the layer. You can handle without it. You can just upload within the function all the node modules or dependencies you need. But it's a much more convenient way to work with the layer. And because it's a convenient way, I can also supply you with this script, which is based on this open source project that I told you about. So you can, this script, whatever it does, it just installs. You can see the Brotli command here. It just installed the Chromium and all the dependencies for Chrome to work great on AWS Lambda. And two things that I added to the script is Puppeteer core, which is just the Puppeteer library, and the Jest that, as I told you, needed to be executed on the Lambda. And this is pretty much the only thing you need. If you will execute it locally in your machine, you will eventually find this file, which is Chrome AWS Lambda zip, and you just need to upload it as a layer to the Lambda service. Go into their UI. It's very simple to work with. Once you upload this zip, you have and you can wire this layer into your function. Then you already have pre-configured Chromium, highly compressed or optimized compression with Brotli. You have Puppeteer core, which is what you need in order to work against the browser. And you have Jest, which we, as I told you, we're running locally. Let's see if we missed anything. No, again, so the function remains the same. We're just setting up our project and we're invoking Jest. Once we are wiring the layer, then we just have everything pre-installed, which is the Jest. And in a second, we will talk about the browser. Last thing, just for you to see, is that I exported the YAML, or like the configuration file for the entire function. You can't use it because I obviously can't share my role and the specific layer, which is private for me. But you can see other configurations that are really important. I will save you a lot of time if you will just copy paste this configuration once you will be in the Lambda console, which is the memory size. It needs to be at least one gigabyte. Okay, so you just pick the number. You can use 3, but it will cost you more. This is for the cost question. This is one of their costing model. It depends on the resource that you will consume. Timeout is very, very critical. The default timeout, I don't remember how many seconds it is, but you will need at least a minute. Not because, by the way, of the setup, just because when you're running end-to-end tests and you will, I don't know, you will load your own project or your own website or whatever, it sometimes can take you even more. So because of like initial setup, so just increase the timeout. And you will see there that the runtime, it can be any runtime you want. Chrome AWS Lambda, the project supports any type of runtime. But I just picked the newest one, which is Node 12. And that's it. This is the only configuration you will need. The memory, the timeout, and the Node 12 runtime. And once the layer is up, you're pretty much settled. Okay, any question for this part? No, great. And the last part, and this is the most important part because this is how we're wiring the actual browser. So far, we talked about how we execute the test, how we set up our Jest environment, and how we execute the test, and how we pre-configure all the dependencies we need and pre-install them. But now is the most important thing is how we, if you recall, the test was a simple test, nothing related to browser. But now we suddenly have a browser test. So the code itself doesn't really matter. It's just a simple test that using the Puppeteer, we will talk about this namespace in a second, but using Puppeteer API of instantiating a new page, you will get this page, you will navigate into the CRL, which is example.com, you will extract the title, and we will just compare this title just to make sure that this test passed. So this is an example end-to-end test. You can, if you install all this stuff locally in our machine, this test should obviously pass. It's a very, very simple one, but it's a real end-to-end browser test. And in order to have, the only thing we need to understand is how we got to access the browser part, which I just use, this is my own namespace I made up with, it's _browser. And this is the last part you need to understand before we're doing our very quick demo, is that when we set up our local Jest configuration in this phase, we also added one configuration. If you recall, before that it was empty, an empty object. So the Jest has a simple configuration called the setup file after environment. What you tell Jest is you tell Jest to run a very, very specific file that has access to the runtime environment of the test. It's a specific notion for Jest, but the general idea is that before your test run, let's say that we have 10 tests instead of 1, is that we can wire up the environment. And if you look at this file, what we do is that we're just reading this, we're telling Jest to look at this file, which is the Jest setup Jest runtime. And this runtime actually does two things. Before all tests are executed, we're accessing, if you recall, we're using this amazing open source project, Chrome AWS Lambda. And other than supplying us with Chromium binary and setting it up and doing all this very fancy stuff, it also helped us to easily launch the local Chromium with some optimized configuration, which you can later on find in the Rx part. Okay, so I just, by the way, just to be clear, I copy-paste this part from Chrome AWS Lambda README. It's nothing special that I did. We just passing in the Chromium arguments that are optimized to run in headless mode and in Chrome AWS Lambda. There are some features that might, mostly related to video or stuff like that might, in theory, not work on Chrome AWS Lambda. But again, this package is very well maintained. So every time there's an issue there, eventually it's being solved if it's solvable. And you can look into the README later. And once we launch this browser, the only thing we do is using just the API. We're just wiring this the browser instance to the global scope of the test. And each test, again, as I told you, this file is executed before all test files are executed. So it's like a global notion of the runtime. So before, what we do is that we just wiring the browser and going back to the test. Going back to the test, we're just using it. And from here on, it's just a normal Puppeteer API. And this is step 4. So it's pretty much everything we need to see. I'll review it once again, and we'll just do a very quick demo. I want you to see it in action. Function, which is the function code, local setup, and whatever you need to do in order to run the test. And the layer, which is all the pre-installed packages you need. The local runner, which is how you override the Jest to invoke your Lambda, and the actual test file. And now let's do a very simple, quick demo. I'll just run our test command for a single file. Great. So honestly, our test passed. It took 8 seconds, but if you look now, I'll run it again. It will take much less. This is the concept which I don't want to talk about of hot encode Lambda. Once a Lambda is spin up, you can reuse it, and it will be much faster. You can see the difference here. And I want you to see another thing. Because we just executed one test, let's try. I just added, I copied the same test, and we just added 2 more tests. Same one, but it doesn't really matter. And now what we're going to do is that we're going to run all 3 at the same time. What I want you to see is the time differences. Hold on. Now, as you understand, we still have some what we call cold lambdas. So the time is similar. 3 tests were the same as the initial cold lambda invocation. But now if I run the same thing again, and again, you can see that the difference between invoking one test, and this is like the wow factor of this approach or this platform, is that executing one test and executing 3 is pretty much the same thing. And I don't want to take any chances, but if I would have copied and pasted 100 test files, it pretty much would have been the same thing. And just for the skepticals of you, let's go to test number 3, right? And let's break it. What will happen here is that, again, pretty much the same time, only this time 2 tests, which is test number 1 and 2 passed, but test number 3 failed. So you can see I'm not cheating you or anything. These are the same tests. We're just copying and pasting its content and execute them immediately on Lambda. Yeah, so if you were real, we would have claps or questions. So you can pretty much ask your final question now. The last part of the lecture, I just want to briefly talk about different features you might need to implement or stuff we implemented in Wix engineering. So if you guys have any questions, please ask them now. I think this is like the most important part of this lecture. And again, as I said, in the last slide, you will see the link. You can actually see, or you can actually do it by yourself. Just get your authentication credentials. Any questions? No? Cool. So for the final part, let's just review just one number you guys need to know that I looked in the numbers like I think yesterday just to get the official numbers. Right over this day, we're invoking over 1 million lambdas, which is different test files for all our projects every single day. Yes, just to be clear, 1 million every single day, meaning that we have millions and millions of Lambda executed per month. And for the person that asked about price, it is expensive, but the value for weeks is dramatic. I think we talked about it at the beginning. It's very hard for me to show you in numbers, but the value is dramatic for very critical project that in the past was very complicated to test. We're now having thousands of tests for a single build, for every PR and every commit and whatever. So I can't tell you the exact numbers because I didn't check it lately. It's obviously we're talking about thousands of dollars. I don't know if it's $50,000 or 60 or even more now, but the value is huge for Wix. And on the other hand, we have to say that we're using like heavy and expensive resources, and we're invoking millions of tests. It wouldn't be the price if the scale was much smaller. So for some of you, the scale won't be that expensive, but it's something you will need to look into. And the value is tremendous. It's not even something that you can measure in money, because the alternative would be to not have these tests at all, or have just a few tests for one project. And when you have, for a mission critical project, you have thousands of tests that are running in a very stable fashion, and you get an immediate feedback. So the value is dramatic. Another question I can see, how much does the dev need to mess with? So again, with all the features, I think we're out of time, so I don't want to break down all the features. But for our devs, we wrapped it in as a node library, as a CLI, like a command line tool that everyone can use. So our developers are not aware of anything of this. They just install a node library, and they have their own. We have our own very simple syntax and our own library for accessing the browser, and it's pretty much work out of the box. But again, no point, including the artifacts upload, but no point of showing you guys, because it's a very specific thing for Wix. But it's very easy to wrap this thing as a node library to abstract away. Any other questions? No. Okay, so if you're interested and if you want to do it on your own, we have our repository called Wix Incubator. Sled Meetup, this is the project name. You can look into it. You can build your own sled, play around with it. If you have any issues or questions or whatever, you can shoot me an email, or just open an issue in the repository, or access me in LinkedIn, whatever. And that's it. No more questions. Thank you very, very much. Although I didn't hear you, I had a lot of fun. And that's it.